Good afternoon, everyone. Now, today's seminar is mainly centered on the person, Mr. Jonathan J. Crabtree, who has just arrived to our campus. In spite of his very busy schedule, in short stay in India, he has agreed, although it's some confusion on 9th February or 8th February. Actually, he understood that it will be on 9th February. But being a holiday, 9th February, I requested him personally that if you can come even in the afternoon on the 8th, then our audience will be highly delighted to hear from you. Now we are eagerly waiting so long from the very morning to hear from Mr. Jonathan J. Crabtree, who is a noted elementary mathematics historian, and he will speak. His talk is entitled on history, mathematics, laws of physics, pedagogy, all the things he will deal in his lecture. Now, I just announce one thing, that we have arranged here the inaugural of the seminar. Now it is declared that Mr. Jonathan J. Crabtree will inaugurate this seminar through lighting of the lamp first with the dignitaries present here. So then Sagotaras all are requested to gather.
As it is rightly said that darkness cannot drive out darkness, only light can do that. Hate cannot drive out hate, only love can do that. Let us wish this light of education take over the darkness of differences, injustice and violences in the world and guide us towards progress, equality and freedom. Mr. Jonathan J. Crabtree. This personality needs no introduction at all. An elementary mathematician, historian from Melbourne, Australia. I would like to request each and every one of you present here to please stand up and welcome sir. Sir, we would like to request you to go to the podium and say a few words and press his occasion. Thank you, sir.
Thank you very much for making me feel welcome. I'm very pleased to be here and I apologise for being delayed, but I'm very, very excited to give you a bit of a background to this. I want to say that this has been a spiritual journey for me. I'm not somebody who went through school liking mathematics. The reason I became a mathematics historian and researcher is because I hated mathematics. For most of my childhood, I failed mathematics at school. I even repeated a year at school. I was not thought to be very clever. But the reason I thought I was not very clever, I discovered the reason why, and you'll be discovering the reason why in my talk. But I just want to say that this has been a remarkable journey for me, and I am so deeply humbled that I've been invited here to talk with you today. And what I'll be doing in this talk is sharing information for the first time. anywhere in the world. I've saved some of the ideas on the interplay between mathematics and physics and pedagogies, and this is the first time I'll be presenting this information anywhere. So perhaps, maybe if some of the people at the back of the room can maybe come forward. I've got a slightly sore throat from talking so much, and it would make it much easier for me if the people at the back of the room came a bit closer so I can talk a bit softer. Because I probably will be walking around the room while I talk. That's going to make my life a little easier. Hello, thank you for having me. This is probably the most important talk I ever will give, because this is really where I'm taking a great risk to introduce a reason why so many people don't like mathematics is because it goes against the laws of nature and it also goes against the laws of physics in some ways. So yeah, I'd also like to thank Professor D.K. Sinha for organising this talk as well, so thank you very much. So let's get on to it. The talk, as you can see, ancient Indian mathematics, pedagogies, and basic physical laws. So before we begin, tell me what you want to see. You're going to have to call out and give me feedback that I can hear. Okay, tell me what you see. Okay. I can't hear you. Now tell me what you see. Okay, what colour do you see? Call out. Blue. Blue. Okay, what colour do you see? Green. Green. Okay. It's very difficult for adults not to say orange when you are seeing green. The reason I've got these slides up and the colour you see is we read this as logical left brain thinkers. We read that as blue. Our eyes are seeing red. Now, my eyes saw mathematics directly when I was a little child, but everybody else was telling me it was something different to what my eyes were seeing. So we'll now start to see mathematics with Indian eyes. So first a question, and I want you to call out the answer. What's -7 minus -4? Is it -11? Anyone agree with that answer? Yes? No? Or is -7 minus -4 -3? Who votes for -3? You've got to vote. Okay. Who votes for -11? Okay? It's a confusing question. And many adults in Australia will say the answer is -11. Because negative numbers and positive numbers, is it negative, is it minus? These are some of the things that become very confusing over the centuries. What about, without resorting to laws, why is -2 into -3 equal to +6? We know the laws of sign. We know that negative into negative is positive. We know negative into positive is negative. We know negative into positive is negative. But why? We learn the laws and we memorize all of the rules. Children do not like memorizing laws and rules without a logical, common sense reason why. Mathematics has become the study and the memorization of laws and rules with no understanding. Mathematics has become memory. And the better your memory, the better you can remember those laws and those rules and those formulas. But if you forget the law, you don't have any mathematical knowledge. I'm going back to before. Children don't like mathematics very much. It's really the only subject where the customers are the children. And the customers don't want to buy what we're selling. But the government says it's the law that you have to buy mathematics at school. And so everyone has to learn mathematics. And too many children, as quickly as they can, they say, stop, no more mathematics. That, I believe, will change in the future. So this character is Podo the puppy. When I was a child, I loved cartoons. All children like cartoons. All children like games. All children like singing. All children like playing. So what I'm doing is I'm going to be explaining the physical foundations of mathematics with cartoon characters and cartoon animals. So yes, there's all sorts of logical, scholarly research behind the scenes. I've looked at the history of mathematics in ancient Greek, Latin, Sanskrit, Arabic, Hebrew, French, German, Italian, Russian, Dutch, Czech, Spanish, Japanese, Korean, Mandarin. All of these languages I've took years and years and years to explore mathematics in about 18 different languages and check the translations and bring it all together. So it's like a 10,000 piece jigsaw puzzle that nobody has ever had the picture on the box. And we haven't known how all of those pieces fit together. And I'm hoping to fit all of those pieces of the mathematical jigsaw puzzle together. So for the first time, mathematics makes total sense to children. Total sense.